Welcome back. Today we're doing a deep dive into something that honestly keeps security folks up at night. SQL injection.
Yeah, it's still a really big deal. Scuthly, as it's often called.
Right, SQL. And our mission today is pretty straightforward. We want to boil down the essential security tips for you developers out there, pulling from, well, ethical hackers and secure coding experts.
Exactly. So SQL injection, it's basically when an attacker manages to slip malicious SQL code into places where an application expects, normal user input.
Like search boxes or login forms.
Precisely. And this lets them talk directly to the backend database in ways the application never intended. They might view data, change it, delete it.
And this isn't just theory. OWASP, the Open Web Application Security Project, they consistently rank injection attacks.
Right.
Including SQL, super high on their list of critical risks. It was, what, third in 2021?
That's right. And what's kind of wild is that even huge organizations sometimes get caught out. It often boils down to how developers handle data that comes from users when they're building those SQL queries.
Because the database engine itself, it just runs valid SQL, right?
That's
It doesn't
right.
care if it's friendly or malicious.
Exactly. If the syntax is correct, it executes. So the core problem is this malicious code getting mixed into strings sent to the database. It exploits weaknesses where the app doesn't properly say, filter out special SQL characters or check data types.
There's no clear line between the commands and the data.
Yeah, that's a good way to put it. The control plane, the SQL commands, gets mixed up with the data plane, the user input.
Okay, so how do attackers actually do this? What are the main ways?
Well, one common way is direct insertion. Think older PHP or ASP code where variables are just stuck together, concatenated into a SQL command string.
Ah, string building.
Risky. Very. An attacker can just put their SQL right into a username field, for example. Then there's indirect injection, sometimes called second-order SQL.
How's that different?
That's where malicious code is first stored in the database, maybe in a user profile or some metadata, and then later, that stored string gets pulled out and used in another dynamic SQL query, triggering the attack.
Sneaky. So they're trying to cut off the legitimate query and add their own stuff.
Often, yes. A classic technique is to use SQL comment characters like the double dash or the hashtag, to basically tell the database to ignore the rest of the original legitimate query after their malicious part.
And they can try this anywhere users provide input. Forms, URL.
Forms, URL parameters, cookies, even HTTP headers. Anywhere data comes in from the outside is a potential vector.
You mentioned different types too, in-band blind.
Right. In-band is where they get results back directly, maybe extra data shows up on the page, or they trigger revealing database errors. Inferential or blind SQL is trippier.
Blind.
Yeah, they don't see the data directly. They have to infer it by asking true-false questions, like, does user ID 1 start with A, and seeing if the page changes? Or they use time-based attacks, making the database pause for, say, 5 seconds if a condition is true.
Wow, that takes patience.
It does. Then there's out-of-band, using a different channel entirely, but that's less common. Techniques include using union to combine results, exploiting errors, those Boolean checks, timing attacks, comment injection, or even stacking multiple queries together.
Okay, so if an attack works, what's the damage? We're talking real-world impact now.
It can be catastrophic. Data breaches are the obvious one, exposing sensitive info like PII, credit cards, company secrets. Think about the Move It transfer breach or 7-Eleven. Big names.
Just getting data out is bad enough.
But they can also modify or delete data. Imagine changing financial records, deleting tables. It can make systems unusable. And if the database user account the application uses has high privileges.
They could take over the whole system.
Potentially, yes. Gain administrative access, maybe even root access on the server. SQL can be just the first step to compromising everything.
And the fallout isn't just technical, is it?
Not at all. Reputational damage is huge. Customer trust evaporates. Then you've got lawsuits, regulatory fines, GDPR, HEAPA, PCI DSS. The costs mount up fast. Remediation, notifications, legal fees. It's incredibly expensive and time-consuming.
Okay, let's shift gears. How do we fight back? Tell us about the White Hat Alliance group idea, ethical hackers. What's their angle?
Right, so ethical hackers, or white hats, are security pros who have permission to try and break into systems. They use the same tools and mindset as malicious hackers, but the goal is to find vulnerabilities like SQL before the bad guys do, so they can be fixed.
They're like security testers.
Essentially, yes. They do things like penetration testing, actively trying to exploit flaws, vulnerability assessment, security audits, sometimes even social engineering tests. They report what they find and advise eyes on fixes.
And from their perspective, looking for SQL, what do they often see?
They often find weaknesses developers might overlook because they approach it like an attacker. They know how to try and bypass simple filters or blacklists. That real-world testing is vital. Certifications like CEH teach this attack mindset.
Now, what about the scripting council, the development communities? How do they help?
These communities are all about promoting secure coding best practices, sharing knowledge, developing guidelines, collaborating, think OWASP again, but also language-specific groups, online forums like Stack Overflow, GitHub.
They create resources, like coding standards.
Exactly. Secure coding standards, guides, cheat sheets, raising awareness about threats like Sequia and how to code defensively. It's about building security in from the start.
So secure scripting means what exactly?
Fundamentally, writing code that prevents vulnerabilities. Key things are rigorous input validation, using parameterized queries, we'll definitely come back to those, and the principle of least privilege, only giving the application the absolute minimum database permissions it needs.
How do these two worlds, ethical hacking and secure development, connect on SQL?
Well, they're two sides of the same coin, really. When an ethical hacker successfully exploits, say, a dynamic query with messy input, it directly proves why developers need to use parameterized queries, which is what the secure development folks preach.
So the hacks validate the best practices.
Precisely. When white hats bypass basic filters, it shows developers that those filters aren't enough. It highlights the need for stronger defenses. It's a feedback loop.
Got it. So what are the common coding mistakes developers make that lead to SQL?
Number one is definitely building SQL queries by just gluing strings together with user input. That direct concatenation is incredibly dangerous.
Because it mixes code and data.
Exactly. Also, insufficient input validation, maybe not checking the data type or length, or using flimsy block lists that attackers can easily bypass. Using dynamic SQL inside stored procedures without care is another one.
And permissions.
Overly permissive database accounts for the application. If the app runs as an admin, a compromise is much worse. Oh, and showing detailed database error messages to end users that can leak valuable information to an attacker.
Okay, the crucial part. What are the best practices? How do developers actually prevent this?
The absolute cornerstone, the most critical defense, is using prepared statements or parameterized queries.
Explain those again quickly.
Okay, think of it like a SQL query template with placeholders for the user data. You define the query structure first, then you safely bind the user's input to those placeholders. The database treats the input strictly as data, never as executable code.
That separation is key.
It's paramount. Almost every modern language and database supports this. After that, use secure stored procedures with parameterized inputs, enforce least privilege for database access, and implement robust allow list input validation.
Allow list, not deny list.
Yes. Define exactly what is allowed, for example, only digits, specific format, rather than trying to guess and block everything bad. It's much safer. WAF's web application firewalls can help as an extra layer, but they don't replace secure code. And finally, handle errors gracefully without revealing details, and log security events.
So boiling it all down, the synergistic tip combining the hacker insights and dev best practices.
It's this. Ethical hackers prove time and again that dynamic queries with raw user input are the main target. Secure development says separate code and data. So the tip is, prioritize parameterized queries for absolutely any database interaction involving user data. Then back that up with strict allow list validation as your second line of defense.
And actionable steps developers can take, like right now.
Yeah, audit your code. Look for anywhere you're building SQL strings dynamically, refactor those immediately to use prepared statements, implement strong allow list validation everywhere you take user input, and institute regular secure code reviews. Make it part of the process.
Excellent. So here's the final thought to leave you with. SQL injection keeps evolving, attackers get smarter. Given that, what truly new approaches, maybe beyond today's best practices, might we need to build truly resilient web applications for the future? Something to think about. Thanks for joining this deep dive.